and welcome everyone to one more lecture of probability and statistics. Today we will derive moment generating function for gamma distribution. M.g.f for gamma distribution. First of all, as we know, M.g.f is denoted by mxt and this equals to expectation of e raised to power tx. And probability function for gamma distribution is f of x equals to integration minus infinity to infinity 1 by b raised to power alpha gamma function of alpha x raised to power alpha minus 1 e raised to power minus x by b beta into dx. This is our formula for probability function for gamma distribution. Now we will derive its moment generating function, and that will be equal to expectation of e raised to power tx, and this will be integration minus infinity to infinity e raised to power tx into f of x, and this will be integration minus infinity to infinity 1 divided by beta raised to power alpha gamma function of alpha into e raised to power tx x raised to power alpha minus 1 e raised to power minus x by beta times dx. Now these two are constants and we can take that outside, so this will be integration 1 by beta raised to power alpha gamma function of alpha, now integration minus infinity to infinity e raised to power tx e raised to power minus x by beta, when a raised to power x and a raised to power y are in multiplication, so their power will be added. Using this property, this will be e raised to power tx minus x divided by beta into x raised to power alpha minus 1 dx. Now we can write this expression as e raised to power, if we will take minus x by beta common, so this can be written e raised to power minus x by beta into 1 minus t beta. Now if we will take x divided by beta into 1 minus t beta equals to u, so x will be equal to u beta divided by 1 minus t beta, and dx will be equal to beta upon 1 minus t beta du, because this whole expression is a constant, and whenever ax differentiation with respect to x equals to a dx. So using this property we get this. Now we will just replace the values. So this expression will be equal to 1 by beta raised to power alpha gamma function of alpha integration minus infinity to infinity e raised to power tx minus x by beta. This was this, so this will be replaced by u e raised to power minus u. Now value of x u beta upon 1 minus t beta raised to power alpha minus 1 into dx. Value of dx is beta 1 minus t beta du. Let me just erase this. So now this is our expression. This is power. Now we can write this as u raised to power alpha minus 1 into beta upon 1 minus t beta raised to power alpha minus 1. Now beta into 1 minus t beta raised to power alpha minus 1 multiplied by beta into 1 minus t beta. So this will, these both, if we will multiply this will be beta divided by 1 minus t beta whole raised to power alpha, and all of this is a constant and we can take this outside. So our expression will be 1 by beta raised to power alpha gamma function of alpha beta upon 1 minus t beta raised to power alpha integration minus infinity to infinity e raised to power minus u raised to power alpha minus 1 into dv. Now this expression equals to, like, gamma function of alpha equals to integration minus infinity to infinity e raised to power minus x raised to power alpha minus 1 dx. If we will replace x by u, we can get this expression. So this will be equal to gamma function of alpha. This whole will be equal to gamma function of alpha. Now putting this value, this expression will be equal to 1 by beta raised to power alpha t of alpha beta upon 1 minus 3 beta whole raised to power alpha into gamma function of alpha. Now this and this will be cancelled out. This can be written as beta raised to power alpha 1 minus t beta raised to power alpha. They both will be cancelled out. So our moment generating function will be 1 minus t beta raised to power minus alpha. This is our moment generating. Till now we have derived that our moment generating function equals to 1 minus t beta raised to power minus alpha. Now we know that mean equals to first derivative of moment generating function and then putting value of t equals to 0 and e of x square equals to second derivative of moment generating function and putting value of t equals to 0 and variance equals to expectation of x square minus expectation of x whole square. That means moment generating function second derivative putting value of t equals to 0 minus moment generating function first derivative putting value of t equals to 0 square. Now if we want to find out mean, our first derivative will be equal to, you know what is differentiation of x raised to power n with respect to x. This is n x raised to power n minus 1 into derivative of x with respect to x. Of course in this case this will be 1. So this will be minus alpha this whole raised to power 1 minus t beta raised to power minus alpha minus 1 into derivative of this. Derivative of this with respect to t will be minus beta into minus beta. So this is our first derivative. Now we will put value of t equals to 0. So this will be minus alpha minus beta alpha beta times 1 minus t beta 1 minus t equals to 0. So 1 minus 0 raised to power alpha minus 1. So this will be 1 raised to power minus alpha minus 1. So this will be 1. So this is equals to alpha beta. And we already know that mean value for gamma distribution is alpha beta mean, and variance equals to alpha beta square. Now if we want to find out second derivative will be alpha beta. This is a constant. Derivative of 1 minus t beta raised to power minus alpha minus 1. So this will be minus alpha minus 1 minus t beta raised to power minus alpha minus 2 into minus beta. Now this will be equal to alpha beta 1 plus alpha minus minus will be cancelled out. Alpha beta square into 1 plus alpha 1 minus t beta raised to power minus alpha minus 2. If we will put value of t equals to 0, so this will be equal to 1 and 1 raised to power whatever will be 1. So this is alpha beta square into 1 plus alpha. Now variance will be this alpha beta square into 1 plus alpha minus our means square, alpha square beta square. So this will be alpha beta. If we will open this parenthesis, this will be alpha beta square plus alpha square beta square minus alpha square beta square. So this will be equal to alpha beta square, and we already know this is our value for variance. That's all. We will make in our next lecture. Thank you.